Let's find some exact values for trig functions, for inverse trig functions, the other three. These are like the three cousins that we don't talk about very much. If I want to know the inverse cosecant of 2, we're going to use the fact that the cosecant is the reciprocal of the sine. It's not so convenient for the unit circle because we can see sine and cosine values and figure out tangent values from the unit circle, but the cosecant is, there's a little more to that. So I'm going to recognize that the cosecant, the angle whose cosecant value is 2, has a sine value of the reciprocal of 2. So the cosecant, inverse cosecant of 2 is the same idea as the inverse sine of 1/2, and that is something that we can look up. It's positive, so we're in quadrant 1, and we're going to find the inverse sine of 1/2 is pi over 6, so the inverse cosecant of the reciprocal of 2 is pi over 6. If I want the inverse cosecant of 0, if I use that same philosophy, then I'm looking for the inverse sine of the reciprocal. 1 over, oh no, we can't divide by 0. That doesn't make sense. So this value we're going to call undefined because I can't talk about dividing by 0, much less the sine of something divided by 0. To put that into some perspective here, if you remember the graph of the cosecant function, something like this. The inverse cosecant of 0, the angle whose cosecant value is 0. Well, the cosecant has this no-fly zone between -1 and 1, where it never goes. So the angle whose cosecant value is 0, well, there isn't one. Or to put it shorter than that, 0 is not in the domain of the cosecant function. So we can't talk about the inverse cosecant of 0 because 0 is not in the domain. Let's look at the secant. If I want the inverse secant of -√2, same idea, the secant is the reciprocal of the cosine, so that'll be the same thing as the inverse cosine of the reciprocal, which we might recognize a little more readily in its rationalized form. -√2 over 2. The range of the inverse secant function is quadrants 1 and 2. The range of the inverse cosine function is quadrants 1 and 2. So the angle whose cosine value is -√2 over 2, we can look and find is in quadrant 2, 3 pi over 4. If I try to do the arc secant of 1/2, I run into the same problem that I did with the secant, and that is that we have this blank space in the middle. 1/2 is between -1 and 1, and that region is not part of the domain of the inverse secant function. So for that reason, since 1/2 is not in the domain of the arc secant function, that value is undefined. The inverse cotangent of -√3, we'll use the same philosophy there. That's the same as the inverse tangent of the reciprocal. So we need the angle whose tangent value is -√3 over 3 if we rationalize that. And that happens well, we have to be a little bit careful with this one. The inverse tangent of -√3 over 3 is -pi over 6, but that actually isn't part of the range of the inverse cotangent function. For the inverse cotangent, we said we were going to look at quadrants 1 and 2, as opposed to the arctangent where we were looking at quadrants 1 and 4. So I'm going to need an angle of a reference angle of pi over 6, but in the right quadrant for the arc cotangent function, which will be in quadrant 2. Pi over 6, reference angle of pi over 6 in quadrant 2 is 5 pi over 6.